Resistance to a change in motion.
To a change in motion.
Okay. All right. And what is the more, I guess, the physics definition of it?
Mhm. It is force times velocity.
That is power. That's not momentum.
Oh, no, sorry. Mass times velocity.
Correct. Yes. So momentum is mass times velocity, and importantly, it's a vector quantity.
Mhm.
And what are the units?
Um, Either kg meters per second or Newton second.
Good. Nice. And what is impulse?
Impulse is force times time.
Okay. So yes, but that's a sort of a rough answer. More precisely, it
Okay.
is product. So let us say impulse is the
Mhm.
product of the average force
Mhm.
with the time over which it acts on the object.
Yes. Mhm.
Or you could say that it is the integral of f dt. So impulse is
Mhm.
also a vector. And how do we connect impulse and momentum?
Um, okay. So, uh, so integral, wait, yeah. So, um, Newton, 1 Newton equals change in P over S. So, force times S equals change in P,
Correct.
where S is time.
That's right.
So, yeah.
So we say impulse is equal to the change in momentum.
Mm-hmm.
And so yeah, so change in momentum is the impulse. So if we want to calculate impulse acting on an object, we can either do it like this. So we could look at the force versus time graph. And
Mm-hmm.
from this graph, how do I find the impulse?
So first I find the F average or the integral, the area under curve.
Correct. So area under the curve is the impulse here.
Mhm.
This is one way to do it. Or I could look at the final momentum and subtract it from the initial momentum.
Mm-hmm.
All right. Okay, so that is impulse. So today we'll look at the conservation of linear momentum.
Okay.
So this is a very fundamental rule in physics, which comes again and again, which is that so the actual rule says that if the external force on a system is zero, then the change in momentum of that system is zero. Meaning the overall momentum of the system does not change if the
Mm-hmm.
external force acting on it is zero.
Mm-hmm.
Okay.
Okay.
So what do we mean by system? So system here refers to any collection of particles. So we could just say a collection of objects. So whether if we are analyzing, let us say, the collision between two cars, we could consider both cars to be part of the system. Or if
Okay.
we are considering the entire solar system, then we could say that the solar system is a system, meaning there are multiple objects which we are
Mm-hmm.
considering as part of one group.
I see.
All right. So that group is called a system.
Mm-hmm.
So the point is that, and obviously we can consider one object to also be a system. So it's not like there must be at least two or something like that. Even one object can be considered as a system. The point here is that if you define your system, the external force on it must be zero for this rule to apply. So Let us look at an example where you have two balls that are going to collide with one another. So
Mhm.
let us say that you have two of these, and this one is coming in this direction, the other one is going to the left.
Mhm.